Boys and girls, this is lesson 12.3, and it is page 544 in your textbook. It starts with a polygon is a closed plane figure, and it doesn't mean plain like, oh, it's just ordinary and it's dressed so drably. A plane figure means it's all in one plane, and remember, a plane is like a flat surface. All of the geometry we're talking about this year is planar geometry, so it's always in a plane. But anyway, a polygon is a closed plane figure made up of 3 or more line segments that intersect only at their endpoints. So these would be polygons because they're all made up of line segments and they don't cross each other. They don't have any openings. These are not polygons. These are made of some curved curves, and this is an oval. And this figure right here doesn't just intersect at the endpoints. It actually intersects at a midpoint right here, so that is not a polygon. And the key idea for this section, interior angle measures of a polygon. So remember, the interior angles are the angles on the inside, of course. And the sum, if you add up all these angles, of the interior angle measures of a polygon with n sides, so that means we can put in however many sides we want, equals this formula right here. The sum, okay, of all of these angles is equal to, you take the number of sides of the figure, you subtract 2, and you multiply by 180 degrees. So if we look at this figure right here, this has 1, 2, 3, 4, 5 sides. So we would take this formula, the sum equals n minus 2 times 180. We would put in 5 for n because that's how many sides there are. So 5 minus 2, still in parentheses, so we do that first, times 180. 3 times 180. And the sum of the sides would equal 540 degrees. And somebody might say, well, how did we get this formula? Why is all of this? And really, it's quite simple when you see it. Just start with any vertex. Like here's a vertex right here. We'll use this one. And we're going to draw as many triangles as we can in here. And this ruler is actually a little big to fit on there, but I have nothing better, so that's what I'll use. So we're going to draw as many triangles as we can from this one vertex. So I'll go like this. And then I can also draw one down to this vertex. And I can't draw it to this vertex because there's already a line segment there. And I can't draw it to this vertex because there's already a line segment there. So I can form 3 triangles here. 1, 2, 3 triangles. And we know that the sum of these angles in a triangle is 180. The sum of this triangle is 180. The sum of this triangle is 180. So this plus this plus this is 180. Now I add this part on, and this part on, and this part on. That's another 180, and this part on, and this part on, and this part on. That's another 180. I have 3 180s. And that is really where this 3 came from. I have 3 triangles times 180, 540 degrees. That's why this formula works. Now, we don't have to figure out how many triangles there are in every polygon in order to do this, but that is where this comes from. If I look over here at this polygon, a triangle, and I start with this vertex right here, I can't connect this with any other lines to make more than just the figure itself. There are no triangles that I can form like I did here, so it's just one triangle worth 180. If I use this formula, S equals 3 minus 2, 3 sides, minus 2 times 180. It's just 1 times 180, which is 180. We already knew that. And now here I've got 1, 2, 3, 4, 5, 6 sides. So by drawing triangles, and I'll start with this vertex right down here. I can't draw one here. There's already a line segment. So I'll start just connecting the vertices that I can. And I can't draw one here because there's already a line segment. So really I got 1, 2, 3, 4 triangles. Okay, but if we use this formula, we'll do S equals, there were 6 sides, so 6 minus 2 times 180, and that equals 4 times 180. So really this number of sides minus 2 is a way to figure out how many triangles will be inside. We multiply that by 180, of course, and 180 times 4 is 720, so 720 degrees. So that's where this formula came up from. We don't have to go through this every time, but it's nice to know where a formula comes from, and we don't just do stuff because somebody told us to. Unless it's your parents, and then you just do stuff because they told you to because you're a kid. That's what you're supposed to do. Over here, there's a little side note. For polygons whose names you have not learned, you can use the phrase n-gon, where n is the number of sides. For example, a 15-gon is a polygon with 15 sides. And if you didn't know what a 5-gon was called, a pentagon, you could just call it a 5-gon, a 6-gon, a 3-gon, I guess, if you never learned the word triangle. But technically, 3-gon is a name for that shape right there. Okay, there are 2 problems at the bottom here. Find the sum of the interior angle measures of the green polygon. So here's a polygon here, here's a polygon here. This one, 1, 2, 3, 4, 5, 6, 7 sides. So we should be in the habit of writing our formula down first. It takes a couple extra seconds. It's a great habit to get into. Now you substitute into your formula. We know it's 7 sides. And don't think to yourself, oh, I don't have to write down the formula. I just memorize it. It takes a couple extra seconds. 5 times 180. S equals 900 degrees. Number 2, this is 1, 2, 3, 4, 5, 6. So start with the formula. N minus 2 equals 180. Oops. Times 180. And 6 minus 2 times 180. 4 times 180. S equals 720 degrees. Okay, so that's how we do those. Excellent. Here's a little side note that I have this teacher book that I go through and I've been using for years now, and I so much focus on this and I rarely look at the information that they give me on the other side, but I did notice this. It says, did you ever wonder why bees use a hexagonal structure for their honeycomb? That's the picture down here. The honeycomb has a hexagonal structure. Why not squares or circles or octagons? It says, draw a few cells of the honeycomb, which would look like this. The real honeycomb would, of course, look more like this picture here. Mathematicians have concluded that a hexagon is the most appropriate geometric form for the maximum use of a given area. This means that a hexagonal cell structure requires the minimum amount of wax for construction while it stores the maximum amount of honey. And that seemed kind of interesting to me, so I shared it with you. So there. In example 2 here, finding an interior angle measure of a polygon. So what we can do is we can find out what the sum of these angles has to be using the formula we learned on the previous page. Then we subtract the angle measures they give us to find out what that given angle measure is. Okay, so for this problem here, we would first find out how many sides there are, and how many angles they are. Always coincide, so we can count up these angles. 1, 2, 3, 4, 5, 6, 7 angles there, so there are 7 sides. So we can do, okay, the sum of the sides will be n minus 2 times 180. And we said there are 7 sides, so 7 minus 2 times 180. And that'll be 5 times 180, which is 900. So now that we know they all add up to 900 degrees, we can write this formula down. We know that all of these added up equal 900. So I can do x plus 128 plus 130 plus 120 plus 115 plus 145 plus 140 equals 900. And 1, 2, 3, 4, 5, 6, 7. Yeah, I got them all. That's awesome. And now I can add all of these up. I actually usually add them in pairs and then just keep getting some partial sums until I get it all the way down. So I have x plus, I know 128 and 130 is really 258. 120 and 115 will be 235. And 145 and 140 is 285. And that equals 900. And now we can do it a little more. X plus 258 and 235. Well, that'd be 3, 2, 3, 4, 8, 9, 493 plus 285 equals 900. And finally, x plus, this will be 877 equals 900. 877, yep. And now I can subtract 778 from each side. X equals, and doing this in your head is okay, but man, so many people make a carrying mistake here. So 8 minus 7 is 1, 9 minus 7 is 2, 10 minus 8 is 2. 122. Now, that makes sense. This is an obtuse angle, so it is going to be greater than 90. Our answer is greater than 90, so it is reasonable. It's not some number greater than 180 or less than 90, so it does make sense. And let's see, 122 is what they came up with. We are fantastic. And by we, of course, I mean me. All right, here we go, finding the value of x. Same kind of problems here. At this point, what you actually should do is pause this video, go through and work these three out on your own, and then check your answer with the video. So I'm going to hope that you paused it already, and we'll work through these. Number 3. So 1, 2, 3, 4, 5, 6 sides. S equals n minus 2 times 180. 6 minus 2 times 180. 4 times 180. And that's 720. Well, now we can go and use that x plus 125 plus 120 plus 125 plus 110 plus 135 equals 720. X plus, and let's try to get all three of these. So 125 and 125 is 250. 370. And add these two up and you get 245 equals 720. And add these, you get a 5, a 1, and a 6 equals 720. Subtract 615, subtract 615. X equals 105. And yep, it's obtuse, but it's close, but it's obtuse. So 105, very good. Number 4. It's a quadrilateral. We already know quadrilaterals equal 360 degrees. So since we know that, we can just do x plus 115 plus 80. And don't forget, this little box means a 90-degree angle, so plus 90 equals 360. X plus 195 plus 90 equals 360. X plus 285 equals 360. X equals, subtract 285 from both sides. And x equals 75. X equals 75. And yep, it's an acute angle right there. And then number 5. One, two, three, four, 5 angles there. So S equals n minus 2 times 180. 5 minus 2 times 180, 3 times 180, S equals 540 degrees. And then we'll add these up. And this one's a little trickier, using a little more algebra, not too difficult if we just follow the rules. We have 2x plus 145 plus 145 plus 2x plus 110, getting all these angles in there, as is, equals 540. Now that I have that written down, I'm going to move this up so we're not falling off the end of the book. And combining like terms here, I have a 2x and a 2x for 4x. 145 and 145 is 290, plus a 110 will be 400. Equals 540. Subtract 400 from both sides. 4x equals 140. Divide by 4 on each side. X equals 35. X equals 35. So if we go back to the picture, this doesn't look like a 35-degree angle to me, but it's 2x. So this is actually 70 degrees, which is an acute angle. Not hugely acute, but acute. So 35 does make sense. Last note on this page, it says, in a regular polygon, all the sides are congruent and all the interior angles are congruent. So these are not regular polygons because their sides are not congruent and their angles are not all congruent. And you might look here and go, well, those two are the same, but they all have to be the same in order for it to be a regular polygon. And on your own problems for this, find the measure of each interior angle of the regular polygon. So all these angles are going to be the same. So we go to number 6, and it tells us it's an octagon. So now we know the sum of the angles will be 8 minus 2 times 180, or 6 times 180. I should have wrote this down. I should have written this down. N minus 2 times 180. Okay. And 6 times 180, 0. 6 times 8, 48. 1080. So all of the angles add up to 1080 in an octagon. But we want each angle, and there are 8 sides, therefore there are 8 angles. So I'll take that 1080 and divide it by 8. 8 goes into 10 once. 8 goes into 28 3 times. 8 goes into 40 5 times. Each angle will be 135 degrees. Number 7, same kind of problem. It's a decagon this time. So it'll be 10 minus 2, because a decagon has 10 sides. That's where the DEC comes from, like decimal. And 8 times 180, 0. 8 times 8, 64. 81440. So all of the angles added up will be 1,440 degrees. And there are 10 sides, so that's nice. We're just dividing by 10. 1,440 divided by 10 is 144. Of course, just moving the decimal one spot. So 144 degrees for each of those angles. And finally, we have this 18 again. Oh, no, 18 gon. And so we'll start with S equals N minus 2 times 180. 18 minus 2 times 180. S equals 16 times 180. That one I am not going to be able to figure out. So 180 times 16, 48, 610, 0, 1, 8, 0, 0, 8, 8, 2. So the sum of all of the angles will be 2,880. If I knew how many it was for 10, which you subtract 2 and get 8, subtract 2 and get 16. If I knew 8 times 180, I should have been able to figure out 16 times 180. Oof. So anyway, now I have 2,880 divided by 18. So 18 into 2,880. 18 goes into 28 once, of course. 18 goes into 108. So 5, 6. Let's try 6. 48, 10. Ooh, good try. And then 18 goes into 0, 0 times, of course. So each angle in an 18gon is 160 degrees. Excellent. The last thing, I hope it's the last thing, it's a long section. Exterior angle measures of a polygon. The sum of the measures of the exterior angles of a convex polygon is 360 degrees. It's always 360 degrees. So they take these exterior angles here, and when they add up, they are 360 degrees. So find the measure of the exterior angles of each polygon. They give you 3, you're looking for the missing one. Here they give you 3, you're looking for, well, you'll have to use algebra for this one. So on this first one, example 4a, they put x plus 50 plus 127 plus 91 equals 360. They combine like terms to get x plus 268 equals 360. X equals 92. So the measures of the exterior angles are 92, 50, 127, and 91. On this one, on example 4b, write and solve an equation for z. Well, now they have 124 plus z plus 26, that's the third angle, equals 360. Combining like terms, they get 2z plus 150 equals 360. And then they subtracted 150 from each side to get 2z equals 210 and divided by 2. So I don't like this because they did 2 steps in one, but then they divided by 2 to get z equals 105. So then you have to use that information, z equals 105, to figure out what the angles are. So 124 stays 124, z will just be 105, and z plus 26 will be 131. Okay, so those are the angle measures. And they want us to do this one on our own down here. Number 9. Well, we know all of these exterior angles are going to add up to 360. So let's write them down. We'll start with this top one right here. That's a 90-degree angle plus x plus another 90-degree angle plus another 90-degree angle plus x. And all of those are going to equal 360. We can combine like terms to get 2x plus 270 equals 360. We can subtract 270 from each side to get 2x equals 90. Divide by 2 on each side to get x equals 40. So these are two 40-degree angles. Find the measures of the exterior angles. 90, 40, not 40, 45. Oopsie. 90 divided by 2 is 45, of course. So the exterior angles would be 90, 45, 90, 90, and 45. At this point, you should go, turn to page 547, work out the odd problems, check your answers in the back of the book, and then on page 548, work out the odd problems and check your answers in the back of the book. If you have any questions or comments, please leave them in the comment section below and I will reply to them. Have a wonderful day.